Alright, so for this 3D milling example, this mold, we're going to work directly from the model. There is no drawing. So we will work with this. We'll make a bounding box. We'll assume that the rectangular shape is taken care of. So we'll face it and start working on the 3D features. Because it depends on in the shop what stock we're going to work with, whether I assign it to be aluminum or steel. So you'll have to adjust speeds and feeds accordingly. So we'll just grab this in a vise from here to here. And then we'll start facing, maybe chamfer the outside, and then start 3D milling. So this is the assignment. Download the model, and we'll transition here, and I'll catch up with merging the vise and all that stuff. Alright, so I renamed the workpiece level 1 part just to have that separate and sort of try to be organized here. We're going to go to File, Merge, and let's bring in our 6-inch curved vise, which you should already have. And it comes in sort of like that, so I'm going to just dynamically move it right now out of the way, or sort of orientated correctly, just to make sure we're going to make an attempt to get in the right spot using this. And I might go to regular dynamic translate. It depends on how it works out for me. So get this thing sort of in orientation. If I just right click fit, get it in the corner, that gets us sort of in the right location. We'll kind of put it in the center. Not super fussy there, because we're only going to make one of these, and we're going to be edge finding or using the probe or the hammer indicator or something like that. So that's good. And then as far as height, we got to find something that'll work. If this is 1 inch, I'm just going to hit green check and get out of here. That's good. The only thing I might do is I might actually just put the jaws on the vise level, and then get rid of the jaw level separate, just to try to stay a little more organized in this example, because we don't have soft jaws or anything like that. This is only one op, or one setup. So let's draw some geometry here. So make sure the vise is the active level, and make sure 3D is on down here, and let's try to do create curve on one edge right there. And then let's go and click on that curve and go to dynamic, and then I'm just going to go right in the middle. And then let's see, we'll go to, let's say, 1 inch, something like that. Should be 1 inch parallels in the set. We'll hit green check. All right, and then let's see where we end up down here. Well, I'll just double check with distance and go from here to there. Looks like that's 735. It should be. So that will work for us. That'll leave us enough on top to work with. So we'll use 1 inch parallels for this example. So we'll move the vise up. So I'll right click, and we will select all entities on the vise level. I will then go to dynamic. From here, in the Z, to the bottom of the workpiece, just like that. Then I'll hit green check. Clear colors. Let's close our vise now. Select these two levels, or these two components, sorry. We'll go to dynamic. From the edge of the vise, in the Y-axis, to the edge of the workpiece, like that. Clear colors. I am going to delete some of these parts of the device we don't need to worry about for us. And then finally, for this setup, I am going to go to planes, and I'm going to do a new plane, or we can drag everything and move it. It's up to you. It probably doesn't make a difference for this one, but we'll just do a new plane. Upper left corner of the workpiece. This will be work offset. We'll manually put it to 0 for G54 and hit green check. So there's our setup. Okay, so we have plenty of room to work with. We have 1 inch parallels. The gnomon setup. We can go and set up our view sheet. We don't really need it, but we'll do it anyway out of practice. So we'll save view sheet bookmark. Rename the view sheet as op1. And then finally we go to mill, and it'll be generic Haas 3-axis mill. And we'll leave it there for now. Toolpath group 1. This will be roughing. Alright. So I'll save my workpiece now. I'm just going to save it as 3D mill 1 on my desktop. And I'll transition here, let you catch up, and we'll start getting this workpiece ready to machine. Alright, so I changed my mind. I want to rename this first toolpath group as stock. And let's do a toolpath group. So I'm going to go to levels. I'm going to do a new level 2. This will be stock. And let's do a bounding box. to achieve that. So we'll go to bounding box, and I'll select the model there. That's good. All right, and the bottom's fine. 1 inch is fine because it doesn't matter. We're going to face the 0, so any little bit up, you know, is not going to make a big difference for us. We want to create a solid and hit green check, and there's our stock. Okay, so for toolpaths, we'll go to stock model. Turn the stock plane off. This will be missile stock. Go to model, select the model, or you can go to levels, right click, and select all entities, and hit end selection, just another way to do it, and hit green check, and there is our stock model. Okay, so I'll turn both those levels off, or the stock model and the level for the stock off. Now I'll do a new toolpath group, and this will be facing. Okay, and facing maybe and deburr, because we'll go around the outside with a chamfer cutter. We'll go to face, 3D chaining, select the outside boundary, hit green check. This part's like, I think, if you go right click and, you know, as any properties to the bottom, it's 2.5 inches, so a 3-inch face mill will work. So facing is good. Tool, we'll go to select tool library, use a 3-inch face mill, make sure that the number of inserts and all that type of stuff is correct. I'm not going to dictate speeds and feeds yet because this material is sort of unknown, so just leave it by default. That's fine. This will be face to 0. Again, this could be steel or aluminum in the shop. For the programming class, it's sort of irrelevant at this point in the game, so leave that alone. Cut parameters, 1 pass, leaving nothing. Nothing else here should matter. Everything should be okay. Clearance I like on. Absolute's fine for all of these for this simple operation. Coolant can be on, and then we'll hit green check. So there's our facing pass. All right. So now let's take care of deburring the outside of the workpiece quickly. All right. Now we may or may not have done this already, but we'll face it. And the reason I'm not worried about creating the other sides or anything, because again, what we use for stock changes. So we could be using 4-inch stock, who knows? So we'll just focus on what's different and new, and then you can create a program at this point that can create, take care of the rest of the operations, or you can present me a process plan for taking care of the other ops. Like maybe if this is 1.5-inch stock, grab it by the 1/2 inch, machine around, deburr, flip it, then face off the 1/2 inch. That could work. Just let me know. This is focusing on mostly just this face and the 3D milling portion. So we'll go to model chamfer, and I'm going to go change geometry and select this outside. And then the tool, if I go to select library tool, I'm going to use the 1/8-inch chamfer mill, but that's up to you. Whatever we have in the shop at that time is fine with me, so that's fine. Cut parameters, we're going to use wear comp, chamfer width 15 thousandths, bottom offset of 5 thousandths, and no depth of cuts, lead in, lead out is okay. We do want an overlap. Nothing multipasses, nothing here. Coolant should be on, and green check. And you'll notice no toolpath appears. So let's go to geometry. Notice this arrow is going into the workpiece. We can right click and we can change side or reverse. We're going to end up reversing because we want to climb mill this when possible. Now hit green check and regenerate, and you'll see the toolpath appears. If we go to backplot and work through this, if the cutter is going a clockwise direction, it works its way around. Okay, so that's it for that. What we'll do is we'll turn the visualization of these off, minimize it, go to machine group, right click, groups, new toolpath group, and this will be roughing. And then we'll get ready to rough out this pocket using OptiRough. Alright, so we'll be in the 3D tool gallery for this. We'll be in a roughing operation. We'll use OptiRough. And then this is our machining geometry selection. Go down to the bottom of the window to select entities, and we're going to select all these surfaces on the inside. Hit end selection. We're going to leave 10,000. So double click the wall and floor stock and leave 10,000. Tool path control, we're going to leave that for now. Tool, in our case, is probably going to be a 3/8 flat ML. so that's fine. And that will be tool 3. And then the speeds and feeds, again, I'm not going to dial that down. I am going to increase this a little bit just for the sake of time of regeneration time. So we'll go like a 250 surface footage at a 2,000 ship load. That's good. Now we can get into the cut parameters. So step over and step down. Okay, so step over, we're going to go 10%. Step down, we're going to work from top to bottom on this. You really should work up if you can, but I think in this example, it's going to be easier on the tooling in the shop if we go from top down. So step down will be 20%. All right, we'll put step up on when necessary at 10%. We can go 25% for step down. And then all this other stuff will leave now. The back feed rate we could increase, but this is such a small mold, I'm not worried about it. Nothing to worry about here for our steep shallow as of right now. Our retracts, we're going to go minimum vertical retract. Arc filtering, we can turn on. It's not going to make a huge difference. It might make a difference in code length, but it shouldn't gouge or anything, so we're leaving so much. So we'll leave this to, let's say, 3,000 total tolerance, and we'll split the tolerance again, as usual, just to reduce the code length. I'll put 3D arc entry motion if we're helixing in. No, nothing for smoothing. This is all pretty standard stuff. So we'll hit green check and let that calculate. And there we go. Now we have a couple of issues. There's one here. All right, if we watch this in backflop. Okay, so let's look at this. Notice where the toolpath is. It's all in the workpiece. See? So let's fix that. Let's get back into 3D OptiRough. And let's get into our toolpath control. I'm going to do include silhouette boundary, or what we could do is we could go boundary chains. We could actually select just the outside of the mold, the shape we want to cut, and hit green check. We're going to stay inside and compensate to center. And let's hit green check and see if that improves. Now these do take a little bit longer to regenerate, so be prepared for that. There's a lot more going on. Notice it. Now the toolpath stays in the center. Okay, good time to save. And then let's go to verify. In the verify settings, stock models, initial stock, fixtures is going to be the vise. Hit green check. Let's go to verify and watch this run. And let's hit play. And I'm going to turn the precision for my video card down a little bit and turn the speed down a little bit. So we'll hit play. And we'll see the cutter working in. And what we're looking to create with our roughing passes is a set of stairs. An even set of stairs along this workpiece so that the roughing tools, you got to think of it as we're just trying to get finer and finer and finer. We're going to switch to a ball cutter soon, or a ball end mill, to get some of that. So there is our toolpath. Okay. Looks pretty good. Let's hit green check. And then I'm going to go into transparent. I just want to make sure that the cutter is getting all the way into the bottom. It's getting pretty far. There's one of our last tool passes. We're in pretty good shape. So I'm going to go back to solid view. Again, good time to save. You want to save these tool paths. They can be somewhat demanding on your computer depending on what you're doing. So there's our roughing. After roughing, I'm going to go into here, and underneath roughing groups, new toolpath group. This is going to be finish, or semi-finish. And then I'll hit save again, and I'll transition here, and we'll come back and do a semi-finish pass. Alright, so let's turn the visualization of that roughing op off. And then let's get up into here, and we're going to go and do a equal scallop or a regular scallop toolpath. Either one will work for us. We'll probably just go to regular scallop. It's a little more traditional. We'll select the surfaces. And then on the wall and floor stock, I want to leave 5,000s. Toolpath control, we'll do the same thing again. And then make sure we do contain the tool tips. We might have to change that in a minute, but we'll leave that alone. Tool, go to select library tool. We'll go to the filter and let's select a 1/4 inch ball mill. Green check. We'll update our speeds. Well, this would be tool 4, sorry. We'll update our speeds and feeds. Let's say 250 SFM at a would say 2,000 ship load is fine. Okay, again, not optimal. I'm just doing this so that it's faster to actually watch it and verify. Again, until we get into our material selection in the shop, this is not going to be critical. You're going to end up changing it anyway. Go to cut parameters. We're going to go to zigzag for this. Turn off, expand inside to outside. The step over, we're going to leave a scallop height of 0.5 thousandths. All right. Steep shallow we could leave alone for now. Everything in here should be okay, except for we're going to go to minimum vertical retract. Our leads and things like that are okay. We'll leave that alone. Arc filtering will turn on. Put that to 2,000ths max, or actually 1.5 is what I'm comfortable with that. And we'll go 50-50 on the splitting between line arc filtering and cut tolerance. Coolant can be on. If I didn't turn coolant on the other one, make sure you do that. That's good. Green check. Let that calculate. And there is our finish pass. Okay. So the only thing I want to do is make sure it's not contacting the outer edge. Looks like it's going right to the outer edge, which is ideal. Right. Let's go ahead and watch these two run. Good time to save. And we'll watch the first op. Speed it up a little bit because we already watched it. And ignore the times. Again, speeds and feeds are going to make a big difference depending on it's aluminum or steel, or even stainless, depending on what I have you actually make this out of. So we'll slow it down now, and we'll go and watch our finish pass. Alright, did pretty good. I'm going to go back and just rewatch and make sure I don't see any major gouging that I don't like. Again, aluminum, you may, or even plastic, aluminum may not matter, but stainless and other, steels, that can be a problem. So we'll slow it down. And it's more into this bottom area that I'm worried about. Just watching in here, watching it work its way in. I think we're going to be good with that. Let's watch over here. Alright, that looks good. So that's a good semi-finished toolpath. Again, save again. We'll go to semi-finish, right-click, groups, new toolpath group. Notice how we're doing a different root system on this one because we want to run these all together, but I like to keep them separate for ease of selection. This will be finish. And then what I'll do is I'll right-click on the scallop I just created, copy, right-click, paste. That'll help us avoid selecting again. We could have done the same thing with the Yapti Rough, but I just wanted to do that again just to show people twice in case you didn't catch it the first time. Hit save. I'll transition here and we'll come back and finish this workpiece. Alright, let's turn off the semi-finished pass and let's focus on our finishing pass. So everything's pretty much going to be the same except for wall stock and floor stock is going to go to 0. And then as far as the tool itself, we could use a 1/4" cutter, but I'm going to use a different one. So if we go to this one, hit green check, and I'm going to do a similar tool, add another, yes, green check. So this will be tool 5, and that'll be a nice, clean, good 1/4" ball mill. You could go to 3/16, but I know I have longer 1/4" ball mills in the shop we want to use. We could speed this one up, so we'll go to like 50 inches per minute. This will be finish. I know I wasn't labeling them all, but I'm trying to get the length of this video as short as possible so you can label how you like. Cut parameters. This I like to go one way. I like to keep the pressure one way. The scallop height or the step over, this can be really fine. So we want like, step overs of like 2,000ths, okay, to get a good finish. Everything else here should be the same except for our total tolerance on this should be what would I pick for the step over? That's one thing you want to work with. So it's like, geez, 40 millions, something like that, or less than that. Yeah, 4 millions. So we'll get into our arc filter. Let's just go 1/10 for this one. And we'll split it, that's fine. All right. One-way filtering will turn on. I think that usually helps me with surface finish, and that's my That's my experience with that. Click green check, and this could take a little bit to regenerate. So give it a minute. If you ever want to see what it's doing, go to View Multi-Threading, and you can see it start thinking and running through the algorithms of all the inputs you just put in. So let this calculate. Okay, so there's our toolpath. You'll see it's very fine. Okay, if we do our advanced display for our vectors, arc midpoints, and endpoints, and turn it on, you'll see how fine it is. Okay, everything's pretty evenly distributed. That's pretty good for this op. As far as finish requirements that we're going to have, you can get real fine, even finer than this. But if we run all three of these, good time to save and run this. We'll rough it out. And again, most of your time is going to be in the finishing, which is normal. That fine step over and very tight arc filtering is what gives you as good a finish as you can get. You see, we're working our way nice and slow. I'm not worried about this type of stuff because my graphics is not set at the highest. Alright, that looks pretty good. Finish looks decent on the computer. I don't see any gouging or anything odd that I don't like. So that one's done. I'll hit save. Now, one of the tricks I'll tell you before I end this video is when you're making adjustments, increase your step over. Okay? Increase this to the last minute because you don't want to have to let that regenerate all the time over and over. Increase that and change that at the last minute to help your workflow in Mastercam, especially if your computer's slow. So that's it for this one. If you have any questions, don't be afraid to ask. One other thing you might want to do, this code is going to be massive. So you're going to want to go to Files, Edit in the code, go to Control Definition. And you're going to want to take the NC output and increase the amount of code. Otherwise, the code's going to rewind every time. So I just go 1 and 1 and add a couple 9s in here. That way, your code, if you got to find out where you are, where you're going, the code won't recycle. So at 10,000 lines, it would recycle. That way, when you're searching for lines of code, it can be a problem. So this is how you increase the amount of code that the machine will kick out and not recycle the line numbers. So hit green check. And then if you post this, I'm just doing the 3D milling portion of it. And this might take a minute. We'll see. Depends on how your computer is. Alright, this program is quite long. Program's 189,000 lines of code. So, yeah, definitely watch your step overs when working with the software. Change that last. So anyway, that's it for this one. If you have any questions, let me know. And thanks for watching.